Today we are doing 6-2 multiplying and dividing radical expressions. And your learning goal is that you will be able to multiply and divide radical expressions. Okay, the first thing that we need to go over is when we can combine radical expressions, they have to have the same root. So for example, if you had the cube root of 6 times the square root of 2, you cannot multiply these because one's a cube root and one's a square root. But if you had the cube root of -4 times the cube root of 2, you can do this one because they're both cube roots. So you will get the cube root of -8, which equals -2. So the first one you would just write not possible or can't do. And then if you can simplify it, you want to keep going so that you can simplify it. Okay, the second example is simplifying the radical. So what you want to do is you want to simplify the cube root of 54. So some people like to do the factor tree. So I know that 3 can divide in here evenly. So that'll be 3. And then you figure out how many times 3 will divide into 54. So that would be 18. And then that's 3 and 6. And then 3 and 2. And so since we're doing threes, we need a group of 3. So this 3 comes out, but we still have a 2 left over. Now for the x's, you could think of the same thing. If you had 1, 2, 3, 4, 5, and we're doing groups of 3, so one group comes out, but we're still left with 2 left over, so x squared is left. Okay, and it's very important that you remember this to leave that cube root on as your answer. And then you're done. Okay, so simplifying a product, you want to make sure the roots are the same, which they are, so you can multiply them together. So 72 and 10 will give us 720. And remember the property for exponents, when you're multiplying, you add them. So I have a total of 4 x's, so x to the 4th, and 5 y's, so y to the 5th. So then I'll break it down. So, and you can do it either way. You can find a perfect square that is a factor of 720, or you can use the factor tree. It may take longer, but whatever way is easier for you. So I know 720, well, I could actually use 72 and 10. And then this will be 2 and 36, 6 and 6. And this will be 2 and 5. So here I got a group of 2's. And then this one I have a group of 2's. And then 6 times 2 is 36. Or excuse me, so that will give us 2 times 6, which is 12. And then we still have the 5 left over. We have 4 x's, so if I group them in 2's, I can take out 2 groups. We have 5 y's, so I can take out 2 groups. However, 1 y will be left over. Now, since this is an even root, even powers, we don't need absolute value. So then you're done. Okay, division. Division works the same way, where you have to have the same radical in order to divide. Or I should say dividing. So example 1, I have 18x to the 5th divided by 2x to the 3rd. Now if you can divide, I would suggest you go ahead and divide them first. So 18 divided by 2 is 9. Remember the property of exponents: when you're dividing with the same base, you subtract the exponents. And square root of 9 is 3. And then your x, square root of x squared, we have two x's and we're grouping them in 2. Then we have just x left over. Now, because both the divisor and the dividend already require that x be non-negative because you're square rooting, you don't need absolute value bars for these. All right, let's try another one. Let's just call this B. Example 1B. And this will be 1A. So now let's do a cube root. And here again, if you can divide them, go ahead. And then remember your exponents, you'll subtract. So we're going to break down 54, if you remember in the previous problem. Okay, so here's my group of 3. So the 3 would come out. And I have 3 y's, so one group of y's would come out. And the 2 remains under your radical. And then you're done. Now let's say they don't divide evenly. Then we have to do what is called rationalizing the denominator. Okay, so what I'm going to do is split them up. Like this. And because we have a cube, then that means that we would need 3 radicals in order for it to cancel. So it's different from a square root. So I'm going to show you down here. And to make everything easier, I'm going to break down 12 to 2 times 3 times 3 so that you can see that we don't have enough of anything to make a group of 3. So what you have to do is you have to make enough, so you have to multiply it. And whatever you do to the bottom, you got to do to the top. So you see how we only have 1, 2? I need 2 more 2's. I need 1 more 3. And I need another y. And then 2 more z's. And I have to do the same to the top. Okay, so on the bottom, now I have 2 cubed, 3 cubed, y cubed, and z cubed. But on the top, I'm going to have 5 times 2 squared times 3 times x squared times y times z squared. Okay, so on the top you notice that I don't have enough to bring anything out, and it's okay. So I'm going to do 5 times 2 squared is 4, that's 20. 4 times 5 is 20. Oh, I'm sorry, I made a mistake. 3 times 2 is 9, times 2 is 18. So I have 2 2's and 1 3. So I only need one more 2. And 2 more 3's. Same with the top. I'm sorry about that, guys. I have to catch myself. Okay, now 5 times 2 is 10, times 3 squared is 9, that's 90. X squared, y, z squared. Okay, now on the bottom, I have enough to pull out a 2, a 3, a y, and a z. So simplifying the bottom, I'm going to have 6, y, z. All right. Now I'm going to give you one to try to make sure you understand it. Okay, I want you to simplify this problem, and then we'll check our answers. Okay, so I looked at the denominator and noticed I only have 1 5, so I needed 2 more 5's, and I had 2 y's, so I needed 1 more y to make cubes. Okay, and whatever you do to the bottom, you have to do to the top. And so in the numerator, I had 7 times 5, which is 175, and an x and a y. Then on the bottom, my 5's, I had 3 5's, so I made a group of 5. 3 y's, so I made one group of y. And then you are done.